Hello, everyone, and welcome to our latest webinar. We're just waiting for a few more people to join, and we will start very, very shortly. Okay, I see quite a few people have joined. So I'm just going to get started. So welcome again, everyone, to the webinar. Just a few housekeeping rules. As always, the session is being recorded. So last time we had a lot of questions from people asking if the session is being recorded. So it is, and you will also receive the recording as soon as it's done by tomorrow or something. We are using Zoom for question and answering, so please ask your questions there. We have reserved quite a bit of time at the end to answer as many questions as possible, so please don't feel shy. And at the end of the webinar, you will receive a survey from Zoom that helps us kind of optimize our webinars for the future. So please do share your feedback. We had a lot of good feedback from last time that we're working on. So hope to have a good session today as well. So without further ado, let me introduce the people that you'll be seeing in the webinar. This is me. My name is Parikshit. I'm the Demand Gen Manager at Deepset. And today, along with me is our host. So basically our speaker, which is Rob. And Rob, if you're there, maybe you can come online. Hello. So Rob.
Hello.
Hi. And Rob has a PhD in linguistics from Stony Brook University. He's also a postdoctorate, and currently we're glad to have Rob working with us at Deepset. And Rob works a lot with our customers, so as a solution engineer, and then he has some very, very fantastic insights about NLP. So it's really awesome that you're here, Rob. And I'd love to hand it over to you. Maybe you can introduce yourself a little bit, and we can get right into it.
Yeah, sure, absolutely. Can you hear me okay? Can you give me a thumbs up?
Yes, I can hear you. Okay, I will stop sharing so you have control of the screen, and then we can get started.
Absolutely. Okay, there we go. So you should be able to see the same slide. Is that correct?
Yes, that is correct. So it's all yours.
Okay, wonderful. Thank you very much. So yes, as Pari mentioned, I come from a background as a linguist. So my PhD was with a focus in theoretical linguistics, but I also did some work in experimental and mathematical linguistics as well. After that, I was a postdoc here in Berlin at an institute called SAS, which is a sort of linguistics-specific research institute. And since 2022, I have been very happily working here at Deepset as part of the solution engineering team as an applied NLP engineer. So that's enough about me. Let's talk about NLP. That was not intended to rhyme, but it did anyway. So for this talk, I'm going to be talking to you about how to evaluate large language model applications, or much more broadly, just how to evaluate NLP applications. So by the way, happy Pi Day to those who celebrate. So before really diving into the meat of the webinar here, I want to start with not quite a warning, but let's call it a cautionary note about what this webinar is, and perhaps more importantly, what this webinar isn't. So here's what the webinar isn't. This webinar isn't going to be me saying, for such and such NLP system with such and such data, the evaluation metrics that you should care about are X and Y, but not Z. In fact, one of my core points that I'm going to be making during the course of this webinar is that this is probably not even possible. Instead, what you should think of this webinar as being about is sort of a much broader perspective on how to approach NLP application evaluation. So it's less about, oh, you should choose metric X, Y, and Z, and much more, what are useful and productive processes and perspectives for NLP application evaluation. Okay, so with that caveat out of the way, Let's talk a bit about what this webinar is going to look like structure-wise. So I'm going to be starting with what I'm going to be calling step 0, or find out what you care about. So basically the premise here is that so much of what you do when you develop an NLP application, as well as when you evaluate your NLP application, is dependent on the nature of your use case. So if you're working with a client, then what does that client want? How are they going to be using it? And I'm going to be arguing that that's actually the most important part of the whole process, right? Next, I'm going to be talking about evaluating NLP systems by running experiments with annotations and using metrics and all of that fun stuff. Then I'm going to be talking about evaluating NLP systems using human feedback. And then following that, I'm going to have a little wrap up and Q&A. So let's begin at the beginning with step 0, or finding out what you care about. So if you take away one thing from this webinar, I think it should be that an NLP application is more than just a sum of some data and some models, right? There's a lot more that goes into an NLP application than that. Now, what do I mean? Well, what I would argue is that the most important step in building an NLP application is defining the use case. And what that means is addressing questions like, what is the business goal of this NLP application? Who are the users, and how will they interact with this NLP system that you're creating? Furthermore, what is the user's workflow, right? So not only how will they interact with this NLP system, but how will this interaction fit into the larger scheme, of their interaction with their work or with the world in general? And a very important point that I want to really drive home is that every use case is different, even if on a certain level, the functionality might look the same. There's always ways in which your use cases differ, and the ways in which these use cases may differ can have very concrete and substantial effects on how you're going to evaluate your NLP system, as well as how you're going to create it and how you're going to use it and all of that. So to illustrate this point, I'm going to discuss 3 sort of hypothetical potential use cases where the NLP system itself looks identical across those 3 use cases, but the priorities for those 3 use cases are going to look extremely different. And as a result, how we are going to want to evaluate these NLP systems is also going to look extremely different as a result. So for the purposes of this illustration, we're going to look at document search on retail catalogs. So basically the idea is you've got a bunch of retail catalogs kind of floating around, and then the user is going to input a query. And then what they're going to get out is some list of sort of the most relevant, in this case, retail catalogs based on their query. So this seems like a really simple NLP system on a certain level. So how can we see some sort of like substantial variation based on the use case? Well, let's go into some concrete potential examples. So for this first one, I'm going to give them the code name of the filter. So the idea is this: say that your client is working in a mergers and acquisitions department of some big firm, and they are looking to acquire some number of smaller retailers. Now, the problem is that there's just too many small retailers for them to be able to do their full research on every single one of them. So what they would like to be able to do is sort of use document search on their catalogs in order to restrict this list to retailers that sell certain kinds of things, right? So the idea is they want to use this document search system to filter their list. And then the idea is that once they have this filtered list, they're going to do their full research on all of the candidates that emerge from that. So what is this potential user going to care about? Well, one thing that they might care very much about is making sure that good candidates don't fall through the cracks, right? They don't want to miss out on a great acquisition opportunity because your NLP system happened to not let them through the filter. Something that this potential user might care much less about is whether the sort of scare quotes better candidates happen to show up on the top of the list, right? Because they're going to do their full due diligence on every company that comes through the list anyway, so they don't necessarily care whether what the ordering of that list is. So that's use case number one. Here's use case number two. I'm going to call it the pointer. So say that you're an app developer or you're working with an app developer. And the premise of this hypothetical app is if someone's working on some sort of home project or something, and they urgently need to buy this thing that they're missing, let's say a hammer, right? And then the idea of this app is that it's going to be sort of recommend nearby stores that are likely to carry this missing object, right? In this case, the client might care a lot about the order to a certain extent, right? So what they're going to care about, if you're looking for a hammer, they want a store that has a hammer to be as high up on that list as possible, right? Because they don't want someone having to go all the way around to 5 different shops before they find a hammer. Something they might care much less about, though, is where the second best result shows up, right? Because if they've already gotten their hammer after item 1 on the list, they aren't going to keep going to other places to try and find another hammer. So that's use case number 2. Hypothetical use case number 3 is what you might call the seller. So the idea is if you're working with, say, a large association of retailers and they're developing a shopping app for customers. And then the idea is that in this case, their emphasis is on sort of diverse, habitually purchased products, so groceries, clothing, something like that. In this case, they would really, really care about the order of those results. And they might want as many relevant retailers to appear as high up as possible. Just because someone found great shoes at the first place they looked for doesn't mean they're not going to go to the second place to find some more shoes, right? So the point here is not that you sort of memorize these hypothetical use cases. The point is that how you're going to evaluate the systems that you develop for these 3 clients, which are going to look functionally the same, right? We're still doing document search on these retail catalogs, but how you're going to judge the relative success or failure of these NLP systems is going to depend very, very much on your use case here. And you're going to hold these NLP systems for these 3 clients to very different standards. Okay, so that's step 0, right? So that's a sort of illustration, and we're going to see this is going to be a running thread throughout this webinar, excuse me, is this idea of being always conscious of your use case and always being conscious of what the client does and does not care about. So now I'm going to talk about evaluating your NLP systems by running experiments using annotations and metrics. So first, let's go over like a basic sort of fundamental overview of how these sorts of experiments are going to work. So annotations are labels that indicate what should happen for specific inputs into your NLP system. So for example, let's say your NLP system is some sort of question answering, right? Then what your annotations are going to look like is possibly, among other things, they're going to include some questions. So hypothetical questions that you might give to your NLP system, as well as what the answer should look like that NLP system should be returning, right? So the idea is that in this case with question answering, your annotations are going to serve as a gold standard, in scare quotes, for comparison to what actually happens. So the fundamental idea of an experiment is that you're comparing what your NLP system actually does to what you've annotated it should do. And then what the metrics are going to do is that they're going to quantify the relationship between the actual results as returned by your NLP system and the expected results as you've annotated them. So just to give a little sort of quick analogy that'll hopefully make this a little bit easier to understand. You can think of annotations as a sort of combination of a quiz and an answer sheet for NLP system evaluation, right? So questions that are the quiz, and then answers that are sort of what your NLP system should be returning in the case of question answering. An experiment involves your NLP system taking that quiz. So you feed it a bunch of questions and you see what the NLP system returns. And then you can think of evaluation metrics as different ways of grading your NLP system's response, right? So, different ways of sort of saying, oh, I think this response comes such and such close to what it should have been. No, I actually think it's such and such close, right? So that's how you can think of evaluation metrics. So as far as annotation, I don't want to spend too much time on annotation. I think a lot of the stuff with annotation is pretty clear, but I do want to sort of like hit on a few important notes about sort of like good ideas as far as how to approach annotation. So first things first, this should be probably obvious, but sort of hammering onto the same core theme that we've been talking about from the beginning, which is that your annotation should reflect your use case. Again, we're always thinking use case first. So what does that mean? Well, one thing that means is that your annotation should show a form of user empathy. So if you're doing question answering, for example, the questions in your annotations should look like the sorts of questions that the users are actually going to be putting in. Another thing is that annotations should be wide-ranging. They should cover a wide range of sort of possible inputs. And you should also make sure that your annotations sufficiently challenge your NLP system. You don't want to make things too easy, or else you're not going to be really testing things. Another note about annotation is that you should be sure that your annotations follow sort of general best practices, and this is something you should make sure that you look up in advance. So just to give an example, if you're doing something where the input's questions, you should make sure that your questions are unambiguous, just as an example. Another thing that's worth noting, when you're doing annotations, annotations should generally be made by domain experts. So, if you're doing question answering with legal documents, someone who's a lawyer or a paralegal is going to have a much better idea of how to interpret legal documents, what sort of questions people are going to ask than, say, an NLP engineer. And as a final note about annotations, then we're going to move on. In my experience, it's much easier to teach people to make good annotations than it is to fix bad ones. So if you're having external annotators like domain experts, I always find that it's worthwhile to really make sure that they know in advance how they're doing these annotations, because it's easier to do this teaching than to go back and fix whatever mistakes they've made. Okay, so that's enough about annotation. Let's get into the fun stuff. Let's get into the spicy stuff. Let's get into metrics. So I've called this little subsection Know Thy Metrics. Now, to sort of illustrate the problem at hand, I want to show you something. I'm going to jump over to deepset Cloud, which is our SaaS platform here. Now, in deepset Cloud, I've run a few experiments here. These are with toy data. So these are with data about Wikipedia entries about jazz musicians, just as sort of toy data, but it's meant to illustrate a very important point. So these are document search pipelines, like what I said before, where you have a bunch of documents, you put in a question, you get some top documents, right? So here we have a sparse search system, excuse me, which is just using word counts. We have a dense search system, which is using a language model. And then we have a hybrid search system, which is using a combination of a language model and word counts. Now, what I have here are these four metrics are evaluation metrics for document search and document retrieval NLP systems. And what you see, so these are all metrics from 0 to 1, 0 being the worst, 1 being the best. And what you see is while they mostly go in parallel, they don't always point in the same direction. So for example, when it comes to these metrics, MRR and MAP, whatever those mean, we'll be talking about those in a bit. It looks like dense search outperforms hybrid search. Great. However, with this metric recall, it looks like hybrid search outperforms dense search. So the question is, and this is the sort of like fundamental question that I want to sort of be talking about, which do we care about? Which of these metrics is more informative as far as determining which pipeline or which NLP system is outperforming the other? And the answer is, you may not be surprised to hear, it depends on your use case. So that's going to be a very, very important thing to bear in mind. Okay, back to the slides. So when we're talking about metrics, when we run experiments, so you've run your experiment, you've had your NLP system, do answer all the questions or return all the documents based on what's in the annotations. One really important point that I'd like to raise is sort of going counter to a very strong temptation, or what may be a very strong temptation, which is don't over-fixate on maxing out your metrics. And this ties into a very, very crucial point, which is that the metrics are not the evaluation. The metrics are a tool for evaluation, right? That's so important, I'm going to say it again, right? The metrics are not the evaluation, they are a tool for evaluation. They're something you use to evaluate. So you can have really successful pipelines, and I've seen this myself, you can have really successful pipelines that don't necessarily show the most stunning metrics when you run an experiment, but where the client is extremely happy with it. And it does exactly what the client wants. It fulfills its purpose. Nobody's confused about what it's doing, and it's working really well. You can also see the opposite case where you have some NLP system that's showing great metrics. It looks great when you run an experiment, but at the end of the day, the client's just not happy. It's not doing what the client is expecting or hoping for this NLP system to actually do. So it goes both ways. Now, of course, metrics are important. They're very useful, but it's just don't miss the forest from the trees, where the trees are all these nice little metrics that we all have so much fun with. Another thing that I'd like to point out, and this is sort of connected to what I was talking about before, is that it's important to avoid the trap of what might be called glamour metrics or standard metrics. So for certain NLP tasks, some metrics get a whole lot of extra attention because they're used for research benchmarking. So basically the idea is anybody who's making models wants to have the state-of-the-art model. What's the state-of-the-art model in extractive question answering, right? And as a way to sort of standardize this, there are certain metrics that are used in order to compare and determine who's got the best model, right? Now, when it comes to NLP research, this obviously totally makes sense, right? If I'm an NLP researcher and I'm doing research on document search or whatever, there's no way that whatever metrics I use can account for every conceivable use case for this NLP task, right? So it makes sense that in NLP research, you would have some sort of standardized metrics. Great, that's awesome. I'm not here to besmirch the fine name of NLP researchers. However, what this does mean is that a metric's value for NLP research should not be equated with that metric's value for your specific use case. It could be that a metric is really great for NLP research, but it's not particularly informative with respect to the particular things that your client or you care about in the development of your NLP system. Another really important point, and this is sort of a more direct connection to what I was showing you in DeepSet Cloud before, is that and this may seem obvious, but it's something that a lot of people, in working with clients, I've noticed that a lot of clients have had some sort of difficulties with this. And so I think it's something that's really worth driving home, which is that you should know what your metrics actually mean and why they're relevant or irrelevant in terms of evaluating the performance of your NLP system. So again, I'm going to go back to document search. It's a nice simple case. And we have this sort of running example of this document search with retail catalogs. So I'm just going to run with that and talk about some metrics for document search. So one of the most prominent metrics for document search is recall. And recall can basically be summarized as follows. If I put in a query, right, if I put in a question, what percentage of the documents that should be retrieved actually are retrieved, right? So that's a pretty simple principle, right? One thing that's really important about this metric is that it is not sensitive to the order of the results. So if you have a list of documents by relevance, if that list has 5 relevant documents, it doesn't matter whether they're up at the top, whether they're up at the bottom, how scattered they are, whether they're at the middle. It just matters if they're there, right? So that's recall. Another metric that you see for document search is what's called mean reciprocal rank. What mean reciprocal rank essentially says is when you put in a query, how high up is the first accurate result, right? So mean reciprocal rank is sensitive to the order of the results that you get, but only up to a point, in the sense that it only cares where the top accurate or relevant result is. If the top one is at first place, great. If the second one is at second or fifth or 100th, it doesn't care. It just matters where the first accurate result is. A third metric that we will often care about for document search is what's called mean average precision, or MAP. And what MAP says is much more sort of demanding. It says when you make queries, how high up are all of the relevant results? So it doesn't just care where the top relevant result is. It's fully order sensitive, right? It cares about the top, it cares about the second, right? So just to see this example here on the bottom, if the first and second are accurate, it's better than if the first and third, but not the second, right? Now, my point is, I don't need, you don't need to memorize these metrics. All I'm trying to show is that different metrics sort of, in a sense, in scare quotes here, care about different things. They illustrate very different things about the performance of your NLP system. And as a result, if you care about different things for different use cases, then these metrics, you're going to weight them differently in terms of their relative performance too. So now with this in mind, let's go back to our previous example of the document search on retail catalogs. Well, in our first case, remember the first case was what I called the filter, right? So this was the mergers and acquisitions department. They just wanted to restrict their list and they didn't care what order the filtered results were in. Well, in this case, it sure seems like recall is going to be a particularly valuable metric for them, right? Because they're not going to get extra noise in their metrics based on what order it's in, because they don't care. All they care about is what makes it in and what doesn't. And that's where recall is going to be very valuable. For the pointer, which was basically just, I need a store that has a hammer. And once I find one, I'm going to stop there, right? So they only care about the top accurate result. So in this case, for them, for their use case, mean reciprocal rank might be a particularly valuable metric, right? And likewise with scare quotes, the seller, right, where they wanted as many relevant retailers to appear as high up as possible, they might care about a more sort of fully order sensitive metric like MAP, right, mean average precision, or like NDCG for those of you who've seen that metric as well, right? So again, the point is not to memorize this. I'm not teaching you a lesson about document search. What I'm showing you is that your priorities in your use case are going to dictate which metrics are most valuable to you. Now, as a final point about this type of experimentation before we move on to getting feedback, is that you should not stop at metrics. Metrics are very valuable, they're very useful, but when you run an experiment, you should also look at the results of your experiments in much finer detail. In order to be able to make generalizations about where your NLP system is succeeding or failing. And what you can also see are cases where the metrics might give a sort of misleading picture of things, where your NLP system is actually doing better or worse than the metrics might indicate. So to give you an example of this, I'm going to jump back into DeepSet Cloud. I'm going to jump to another workspace. So this is, I'm just going to jump to the experiments. So in this case, this is again with these sort of Wikipedia data about jazz musicians. So again, this is a toy example, but once again, it's sort of illustrating a very important point. So here we have our experiment. We have a couple of relevant metrics here, right? So I'm going to click into our experiment. I'm going to scroll down a bit. You see a little bit more about the metrics, but for now, let's put aside the metrics and let's look at the actual results that we got. So what we see here is we see all the questions in our annotations, the sort of quiz questions, right? We see the predicted answer, which is the answer that the NLP system actually came up with. And then you see, for example, the expected answer, and the expected answer is what was annotated, right? So that's what the annotator said the NLP system should be giving as a response to this question. And then you see here some scores indicating, how well the NLP system performed for that question, right? Now, if you scroll down here, what you see is in some cases, it is just a straight up wrong answer, right? So here the NLP system returned the famous door as the answer when it was actually Leroy's, as far as where it was Count Basie's first consistent gig. So here, the fact that your F1 here is 0 makes sense. But there are some other cases where this metric doesn't necessarily actually reflect how well the pipeline did. So to give an example with this question, why did Art Tatum's music become less popular in the late 1940s? So the expected answer, what the annotator put, is the advent of bebop. What the NLP system said is he continued to play in his own style. Now, I would argue that that's not 100% accurate, but it's decently close, right? He continued to play in his own style while bebop came around. Bebop is a subgenre of jazz, but the metric says, oh, that's actually a 0. That's as wrong as it could have possibly been, right? So this is one of those reasons why it's really important that you also look through the results so that you can say, oh, actually, this answer wasn't as bad as it looked, as well as trying to get generalizations about what types of questions are successes or failures. Okay, so we've talked about evaluating NLP systems with experiments using annotations and metrics. Before we wrap up, I want to talk about evaluating NLP systems by using human feedback. That is, by allowing people the opportunity to look at what the NLP system does and say, oh, that's great, that's not so great. So I've talked to you all about these annotations, all these metrics and all that, and this looks really nice. And these experiments are really easy. You can run them repeatedly. You get these nice quantitative metrics. So you might be asking, why even bother getting human feedback, right? What is the value of getting human feedback if you can do all these experiments on a whim? Well, there's a few different answers to this question. One of them is some NLP systems are less conducive to experiments with annotations and metrics than others, at least with the current metrics that we've got. So for example, if you look at generative question answering, which is where you put in a question and then the model, rather than like hunting for some substring of text that answers the question, the model will generate its own text that answers the question. That's great. That's a great kind of pipeline. The problem is that if you do annotations where you have a question and an expected answer, it could be that the generative system, generates an answer that works just as well, but doesn't happen to match up, word for word with the annotated answer. And a lot of these metrics are based on things like word count and substrings. So you could have a case where a generative pipeline generates a fantastic answer. It just happens to fail the very specific word counting metrics that are used for that task. Sometimes, and we've already seen an example of this, the metrics that are used don't capture human judgments about how good an answer is, right? And so in those cases, it would be much more informative to have a person saying, oh, that's actually a good answer. Oh, that's actually not so good an answer. Another reason why you might want to get human feedback is to get details and information other than just pure accuracy. So for example, you might not just care about whether the answer that the NLP system gave was true. You might care about whether the answer that it gave was polite or offensive or informative, or in the right language, which can be an issue with a lot of multilingual models. You want to make sure it's answering in the right language. Okay, so what should feedback look like and who should give it? Well, this is a lot like what we were talking about with annotation, where the questions that people give feedback on should show user empathy. They should look like the sorts of questions that users are going to ask. They should also be wide-ranging. They should cover a wide range of possible inputs. So you're really testing your NLP system on a bunch of different possible inputs. And they should also challenge your NLP system. You don't want to make things too easy, because if you make things too easy, you're not going to meaningfully be testing. And again, much like with annotation, often the best feedback is given by domain experts, again, for more or less the same reason. If you have a generative question answering system with legal documents, then lawyers and paralegals are going to be much better than me at telling you how good an answer is. And finally, you should make sure that your feedback is systematic and focuses on what's relevant to the particular use case at hand. Now, what kinds of feedback might you want to collect? Well, sometimes the simplest ways are the best ways. So oftentimes, in my experience, a simple thumbs up and thumbs down can give you a lot of information as long as people are giving enough feedback, because that gives you enough to make generalizations about, oh, why questions are doing better than what or who questions, right? That's kind of the opposite of how it always turns out, but this is a hypothetical example. You can also have users input tags, right? They can tag responses as harmful or offensive. They can tag them as containing personal identifying information. You can have a tag that says, oh, this came back in French, right? You can also use something that are called Likert scales. So this is something where you might not be familiar with the name, but you're certainly familiar with the phenomenon. That's if you've ever seen questions like, on a scale from 1 to 7, how strongly do you agree with the following? Right. So that's called the Likert scale. And those are very common, coming from the cognitive sciences myself, you see those a lot there. You see them a lot in business applications as well, and they're very useful here as well. You can also directly compare NLP systems. So you can put in a question, have two different NLP systems provide the answer, and then you can have your user select, you can ask them which of these answers is better, and you can have them choose. And that allows for a much more direct comparison. So if you've whittled it down to two candidate NLP systems, that can be a very good way to choose between them. And then, of course, there's a good old comment box. Now, comment boxes aren't going to be as useful as far as any sort of quantitative study, but they're going to be very useful in terms of giving much more fine-grained feedback that you otherwise might not be able to get when you're using some sorts of other feedback. So to sort of illustrate the range of possibilities, I'm going to start by actually jumping back into DeepSet Cloud. So I'm going to go to another workspace of mine here. Now, this workspace, the documents are financial disclosures from large tech firms. So companies like Amazon, companies like Apple, things like that. And so this is the pipeline that we're looking at is a generative question answering pipeline, right? So you put in a question and it generates novel text to answer it. So let's put in a search. So for example, one of the companies that's in there is Amazon. So I can do, what are the greatest risks faced by Amazon? So now this is accessing, so this pipeline uses OpenAI's GPT-3 model. So we're just waiting for their API to get back with the response. And now they've gotten back with the response. So the response that they have is the greatest risks faced by Amazon include the inability to negotiate acceptable terms, et cetera, et cetera, et cetera. So this answer looks great. So I can just give this in the UI. I can just give this a correct answer, click. Awesome. And I can even go into my pipelines and I can click, this was the one that I used. And I can see some summary information about the feedback that I've gotten so far. So 6 correct answers, 1 wrong one. So 86% accuracy, that's not bad at all. And I can also scroll down and see, oh, what are the questions that I've put in and what sort of feedback have I given? You can download it, right? So this is already, I can speak from experience, very valuable information as far as evaluating the performance of an NLP system. Now, you can also go for a little bit of extra credit if you want to do some more custom feedback. So this is something that I developed in Streamlit in like an hour or two. And the NLP system is still hosted on DeepSet Cloud, but this is just a sort of app that accesses the DeepSet Cloud via the API. So again, what you can do is, what are the greatest risks faced by Amazon? Again, we're waiting for our good friends at OpenAI to get back to us. Let's see. There we go. Okay, great. And so what you see is you see the question here, you see the answer, again, is the same, right? And then, you can just go nuts as far as what sort of feedback people give. So you can have people add tags about whether it's in the wrong language or whether it's inappropriate or harmful or offensive. So you can, click all these tags. Again, this is extremely quick in Streamlit, and this can be a really great way to sort of collect a lot of extra information using an NLP system that in this case is hosted on DeepSet Cloud. And then here are some examples of Likert scales as well. So you can say, oh, I find this response to be very truthful. This one is something, pretty informative, and it's very polite. And you can give, whatever commented feedback, whatever you'd like, right? So this is just an example of something that you can really quickly throw together to collect some really much more fine-grained custom feedback on top of, what is still very, very valuable thumbs up, thumbs down feedback. Okay, on that note, I've been blathering on long enough, so I'm just going to wrap up and move it over to the Q&A. So in summary, the most important part, what I've argued is that the most important part of the NLP development process is getting a clear understanding of your use case. Right? We've seen that affects every aspect of the NLP development and evaluation process. What we've also seen is that for experiments with annotations and, sorry, that should say metrics, you should make sure that your annotations reflect your use case. You should know what your metrics mean. That is extremely important, and how that relates to your use case. Again, everything comes back to the use case. You should look beyond the metrics and see what your results are really saying that your metrics might not be capturing. And for gathering feedback, again, you should make sure that your feedback pertains to your use case. Again, we're always use case focused. Your feedback should be systematic. And remember that there's lots of methods for collecting feedback. So consider what's best for you and for your use case. All right. Thank you all very much. I appreciate your time. And I think we can now move on to a Q&A session.
Thank you so much, Rob. I think we can, maybe let's stop sharing the screen so that people can see you clearly. And I have to say, there has been a lot of questions coming in. So we've been answering them in the background, but we have left like the awesome ones for you. So, and thank you so much. And just a little note for everyone listening, if you're raising your hands, that's a feature that we're not able to use right now. So just a shout out to Peter, I think, who raised their hands, and there was one more person. I can't see you anymore. But if you have a question, just put it in the Q&A section, and I'll make sure that that it shows up for Rob. So thank you so much, and apologies. So firstly, let's get started. So question for you, is an F1 score based on Rouge score when you compare expected answer and the predicted answer? That's a straightforward question from Nora.
Yeah, so thanks for the question, Nora. So Rouge is actually a sort of a generalization of F1. So Rouge is, so you might know it as like Rouge 1, Rouge 2, et cetera, right? So Rouge 1, which is just F1. And Rouge 2 is F1, but where you're not considering sort of individual words, but n-grams, right? So pairs of words next to each other. So Rouge, just to sort of sum up, yeah, is a sort of what you could call a proper generalization of F1 as a metric.
Awesome. So there were also a few questions about evaluating summarization. So Basant has asked, do you guys have any suggestions for evaluation of summary text, right? Also in general, like, is there a place to get inspired about evaluation schemes and metrics in general? So that aren't just like state of the art. So.
That's a really great question. So from what I've seen for text summarization, it looks like Rouge seems to be, and I will preface this with the fact that I am not an expert in summarization, but it does seem like Rouge seems to be the most common metric used. Now, Rouge does run into the same problem that I was talking about with generative question answering, which is basically that if you have a text and you have some annotated summary that says like, oh, this is what the summary should look like. If you have a summarization NLP system that is generative, that generates novel text, it might be that it does a great job, but the word by word matchup doesn't necessarily work all that well. The outputs are great. It just doesn't look exactly like whatever you annotated. But as far as I know, I mean, I'm sure that there are better metrics out there. If I were developing an NLP system that was doing summarization and a generative summarization, and I had all the money in the world, I would definitely be focusing more on feedback in this case. And having people rate the feedback and having comparison of feedback for different NLP systems. I apologize if that's not a very satisfactory answer to your question in the sense that I haven't given this is a great metric, but for what it's worth, that's how I would approach it.
That's nice. I think there's also another one about evaluating responses. So there were a few questions about evaluating responses created with a generative model. Like, could you give some more insight on that one?
Yeah, so I'm not sure if folks mean with like experiments and annotations and all of that, or with feedback. But I mean, that's another one where, like, to just go with the example that I kind of was running with this little sort of cute little Streamlit app, that I made. The important point to me is to focus on the things that you actually care about, and how you care about them. So just to give an example, I had harmfulness and offensiveness as a tag in that Streamlit app. I didn't have it as a scale, right? And that's a very specific decision that you're making. What you're saying is, I don't care how offensive something is. If something's offensive at all, I want to know that, and I want to prevent that, right? So what I would say is, when you're doing, like, for example, with feedback, what I would say is you should always be really aware of what you care about and how you care about it, in terms of what sort of feedback you're asking about, and whether it's a scale, whether it's a tag, whether it's a comment box. As far as metrics, I think, so one thing, if you're doing generative question answering, for example, as I mentioned before, a lot of the metrics are sort of word count based, right? And that might not be great for the same reason I mentioned for summarization just now, where it might be that it's a great answer, it just doesn't match up word by word. One metric that you can use that might be more informative if you really want to use metrics, is a metric that was actually developed by some of my colleagues here at DeepSet, which is called semantic answer similarity. And what semantic answer similarity does is it takes a language model, and it encodes the expected answer, right, the annotated answer, and whatever answer the NLP system gave, and then it sort of computes their similarity based on those, right? And so basically what my colleagues showed is that tracks pretty well with human evaluation as well. So that can be a very useful metric for generative systems if you don't have the resources to collect feedback.
Got it. So there's a question here by Gert. It's how much disagreement between human feedback is acceptable? So.
Oh, that's a good question. So meaning like, So the idea is like, if, to give an extreme example, if 99% of people find an example good, or find a response good, and 1% find it bad, yeah, that's a really cool question. It's a really interesting question. I think the somewhat less exciting answer, but unfortunately I think it's the accurate answer, is that it really depends on what your priorities are as far as the use case is concerned. Just to give an example, if you're doing question answering for retail catalogs, you might, the stakes might not be that high. So you can tolerate some disagreement about what's a good answer, and you can sort of like live with that. If you're doing question answering on medical documentation or legal documentation where the stakes are very high, you might have a much lower tolerance for any sort of disagreement. And you might even have a lower tolerance for other quirks of generative NLP systems. So like generative NLP systems tend to what we call hallucinate, where they'll just kind of make stuff up. And if you're doing generative question answering with legal documents, that might be really, really bad in a way that it wouldn't be for retail catalogs. So I think, again, it all just comes back to that very first point that I made, that it really depends on your use case and your priorities for your use case.
Got it. Okay, I had another question from Io this time. There's a bunch of them, so I'm just going to pick out a few that are relevant here. So furthermore, in this distinct domain from research, is it truly necessary to possess quantitative metrics when human feedback holds a greater significance? So, I mean, in the lines of what you were talking about just now.
That's a good question. So what I would say is it's definitely still valuable. So for example, I am not an NLP researcher by trade, right? I make applications, NLP systems for clients, right? But we still care very much about metrics, even if they might not be as informative as feedback, because what experiments with annotations allows you to do is really quick, iterative experimentation, right? So what I can do is I can have, if I have these annotations, I can run an experiment, see the results, tweak some tiny parameter in my pipeline, and then just run the experiment again, right? If I'm collecting human feedback, that involves, I might have to pay people to give feedback, and I can't just do it anytime I tweak my pipeline, right? So there are advantages to collecting annotations and doing experiments that way, which is just that you can do things fast, and really iterate and sort of like tweak your parameters for your NLP system as quickly as possible. And then maybe at the end, if you can, feedback is awesome and it can give you a better idea. But I would say that there's definitely still a value for doing experiments and knowing your metrics for exactly that reason.
Got it. So another one, this one's anonymous, unfortunately. So you mentioned all of these different kinds of feedback, tags, scales, etc. How can I tell which one I should use?
Yeah, that's a good question. So this sort of connects back to the point that I was making before, that it's really about what you care about and like sort of what information you care about. So like the example that I gave of offensiveness, right? Where generally speaking, we don't want our pipeline to be, our NLP system to give responses that are offensive at all, right? So in that case, I need you to tag it. I just need yes or no for that. Whereas, how truthful a response is, I might care about whether it's mostly true or completely accurate, in which case, a sort of scalar input might be more appropriate. There's a whole field in psychology and statistics called theory of measurement that's relevant here, but you don't need to have some sort of PhD in statistics. Trust me, I don't. But that's what I would say, is be very aware of whether you care, in what way you care about different kinds of things.
Cool. So the next question, again, it's how does the evaluation result actually benefit fixing the pipeline? For example, the documents may not be segmented properly and it may lead to wrong answers. So any comments on that?
Yeah, that's a great question. So let me give an example. So when you do extractive question answering, So extractive question answering is where you put in a question, you got a bunch of documents, you put in a question, and then you get sort of an extract of text from one of the documents as an answer to that question, right? So the way that we often will do that is through what we call a retriever-reader pipeline. So the idea is that you have a retriever that takes all of these huge a number of documents and restricts it down to just 20. And then it feeds those to what's called a reader that looks through those and gives you the actual answer to that question. Well, one way in which your metrics can help you is if your NLP system's not doing well, it can help you find what the bottleneck is. So is the bottleneck, is the retriever retrieving the wrong documents? Or is the retriever doing a great job and the reader is just not finding the right information there? So not only can you use these experiments and metrics to find if your NLP system is working or not, but you can also use it to find where exactly it's succeeding and failing and how.
Makes sense. Okay. Probably we have time for one more question. So, so you said we should look at the actual results of the experiments and not just the metrics. So can you go into a little bit more detail on what you're actually looking for? So,
yeah, absolutely. So one thing I'm looking for. So one of the things that I did mention in the talk is how much are the metrics actually reflective of the NLP system's performance, right? So it could be that it's spot on, it looks bad and it is bad, or it could be that it looks, or it could be that it looks less good, but actually it's performing much better for the reason that I showed, where the metric just fails to capture it. But I would say the main reason that I use it is to be able to sort of make meaningful generalizations about where my NLP system is failing or succeeding. Is it giving answers that are too short? Is it doing better with yes, no questions than with what, why, who, when, where questions? So, and that's something where you can only look at individual examples and try to sort of make generalizations from those. So that's, I would say, the main reason why I think it's especially important to still, even after you've got your metrics, look at the individual responses.
sounds good. I think that's all the time we have today for Q&A, Rob, but thank you so much. There were like a lot of amazing comments about the presentation itself and a lot of good questions, actually. I do have a few slides for everybody who's still here. So let me just share this very quickly and then we can close. So thank you so much, Rob. And just for you guys to know, you can keep following us, DeepSet, on Discord. So Tuana is very active there along with our developer community. So please post your questions about Haystack there. Please join the community, talk with people who are building applications. We keep updating all of these upcoming sessions on LinkedIn and on Twitter as well. So there's a lot of interaction that you have there. So if you want to stay updated, you can always follow DeepSet there. And that's about it. Thank you so much. It was really nice to have this session today. And I hope to see you all very soon in the next one. And take care. We'll send you the recording in as soon as it's ready. So take care and bye-bye.